Hello everyone. Today I am going to discuss about pressure or force and vibration measurement, which is the important part of instrumentation and control, and this part is based on the strain gauge. What is strain gauge? It is an electrical conductor whose resistance changes as it is strained. The strain gauge principle based on the measurement of change in resistance, capacitance or inductance that are proportional to the strain transferred from specimen to the basic gauge element. Now the principle of strain gauge, and this is the principal operation of strain gauge. The strain gauge is tightly bounded to a measuring object so that the sensing element may contract according to the strain borne by the measuring object. When a trace is applied on the metal conductor, its resistance changes with the change of its length and across cross-sectional area of the conductor. Resistance of the conductor under trace is also changed due to the change in resistivity. This property is also known as piezoelective or piezoresistive effect. That is why strain gauge is also known as piezoresistive strain gauge. This is the classification of strain gauge. Strain gauge mainly divided into four parts: wire, foil, thin film and semiconductor. Wire strain gauge is divided into two parts: bounded and unbounded. Bounded strain gauge is divided into four parts: flat, wrap, single and oven. In strain gauge, the relation between gauge factor and Poisson ratio is the main important part. The relation based on the R is equal to rho L by A equation, where rho is the resistivity, R is the resistance, L is the length and A is the cross-sectional area. And this is the mathematical expression between gauge factor and the Poisson ratio. Now the topic of damping strain gauge is come. What is damping strain gauge? It is mainly used to shape the original strain gauge. It is obvious that the temperature of strain gauge should remain same throughout the experiment, as the change in temperature produces change in resistance of the gauge material to change its resistivity. That is, even though the load body is unstrained condition, the change in temperature causes the change in resistance of the strain gauge and leads to the information about the load body. This solution lies in having two identical gauge. One is dummy gauge and other is active gauge. In the unity ratio Western bridge, the dummy gauge is connected to the identical surface, kept free from any stress when both structures are under stress condition, and at the same temperature the bridge is balanced. An equal rise in temperature of both the structure raises equally the substance value of both active and dummy gauge, and bridge still remains balanced when the structure is strained. The resistance of the active gauge only goes up and unbalanced voltage is proportional to the strain. However, for those that do not have any capability, they can be temperature compensated by the use of dummy strain gauge. Now, semiconductor strain gauge. Semiconductor strain gauge are used where a very high gauge factor and a small envelope are required. The resistance of the semiconductor changes with change in applied strain, unlike in the case of metallic gauge where the change in resistance is mainly due to the change in dimension. When strained semiconducting materials such as silicon and germanium are used as resistive material for semiconductor strain gauge. The gold leads are usually employed for making electrical contacts. There are some advantages and disadvantages. The main advantages are, as the semiconductor strain gauge have very high gauge factor, they are capable to measure very small strain. They are chemically innate and have low cross sensitivity. They are free from hysteresis effect. And last one, it has high frequency response. The disadvantages: they are expensive, it has poor linearity, it is highly sensitive in temperature variation. Now, one of the most important part in strain gauge chapter, this is the piezoelectric transducer. It is explained by the displacement of ions causing the electric polarization of the crystal structure unit. When an electric field is applied, the ions are displaced by electrostatic force, resulting in the mechanical deformation of the whole crystal. The above phenomenon of the crystal known as piezoelectric effect, and the material shows the effect known as the piezoelectric material. The principle of electromechanical energy conversion is utilized in construction of both mechanical to electrical and electrical to mechanical energy conversion transducer. Piezoelectric effect is possible only in crystal having asymmetrical charge distribution, so that lattice deformation occurs only due to relative displacement of positive and negative charges. This displacement of the internal charges produces equal external charges of opposite polarity of the opposite side, and these external charges can be measured by measuring the potential difference across the electrodes filled in the opposite side of the crystal. The material used for piezoelectric transducer are quartz, terminal, aluminum, hydrogen, phosphate. It has some advantages and disadvantages. The advantages are no need for an external forces, easy to handle, high frequency response. The disadvantages are it is not suitable for measurement in static condition, it is affected by temperature, the output is low, and it is very difficult to give the desired shape to the material and also desired strength. The application of piezoelectric transducer are, it can use as force transducer, strength transducer, torque transducer, pressure transducer, acceleration transducer, etc. Thank you for watching this video. If you have any query, you can freely contact with me.